So today I made a short video about geometric series, and in that video I used this example. So it's 1 plus a half plus a quarter plus an eighth and so on, and you keep adding infinitely, then you get that this thing is equal to 2. And this is just part of a more general family of infinite sums called the geometric series. Now what is that? Well, we're going to start with 1 and we're going to add r, and we're going to add r squared and r cubed and r to the fourth and so on. So what we've done here is we've taken this term, we've times it by some ratio, and then we've added it. And then what we've done next is we've taken this term, we've times it by that same ratio, and we've added it. And we keep on doing this all the way to infinity. And what's special about this, we're going to call this series S. Well, it has this property of, let's just times the whole thing by r. So we get r times s here on the right hand side, and 1's going to become r. R is going to become r squared. R squared is going to become r cubed. R cubed is going to become r to the 4, and so on, all the way to infinity. And what you're going to notice is that, well, this guy here is just the same thing as this up here. So it's this nice little sort of symmetry that we've got going on. And so what I'm going to do is I'm just going to plug this in. So we know that this is rs, so I'm just going to plug that into our first equation. So we get 1 plus on r times by s is equal to s. And then if we do some manipulation, some algebraic manipulation, we get that s is equal to 1 divided by 1 minus r. Alright, so let's talk a little bit more about this. And let's do some examples. So the thing that we should really be cautious of is that the magnitude of r has to be less than 1. Notice how I said magnitude as well, so that includes negative numbers that are between -1 and 0. So this formula will work for minus a half, it'll work for minus a third, minus 5/8. This will also work. As long as the magnitude, so that's the absolute value, so if we just forget about this negative sign, we don't care about that. All we care about is that its size is less than 1. So let's run an example here with negative a half. So what would that look like? So we got 1 minus a half plus 1/4 minus an eighth plus 1/16, and keep on adding and subtracting all the way to infinity. And according to our calculation, this should be equal to 1 over 1 minus 1/2. And let's think about this. So we got 1 plus a half, so that's going to be 3 halves. So if we take the reciprocal of that, then we're going to get 2/3. Alright, that's nice. So just one last thing to mention is, well, let's maybe try to sort of cheat our way into the series. And what do I mean by that? So why can we not look at something like 1 plus 10 plus 10 squared plus 10 cubed and keep on going? And then there's not really any reason why we can't just say that, I'm going to put a question mark here because we're not really equating it. So why is this not equal to 1 over 1 minus 10? Like, we can clearly just plug 10 into this right hand side, and the answer to that is because of this sort of bound that we have here. So we have to respect our initial conditions. What we've done here is a process that's known as analytical continuation, and if you look into the Riemann hypothesis, you'll probably hear a lot about this, but you'll know that it's not really equal to. Basically what we're saying is this series that we have, this whole 1 plus a squared dot dot dot, it looks like this function on this interval, but that's as far as it goes. It looks like something on a particular domain, and that's about it. And that's just kind of a more higher level thing. Basically, if you're not operating within your bound, you can't allow it. Thank you for watching, and like and subscribe and ask me questions over on Reddit. Thank you very much.